scientists are unraveling the mysteries of fires.
The key factor now is how can we make use of our NASA data?
From space, the sky, and on land, NASA is working to help first responders as fires burn.
We had no visual of which fires were burning where.
Track smoke that harms human health.
We have to learn from this.
And understand the impacts of fires in a changing climate.
One of the basic tenets of NASA was to study the Earth, study the home planet.
NASA is studying fires in the field right now in order to answer some of science's biggest questions.
Hello, and welcome to NASA Live Science, an opportunity for you to come behind the scenes and get to know your space agency. I'm your host, Leslie Garrison, and this show is all about you being able to interact and connect with our scientists and subject matter experts to ask questions and get the answers. Visit us during the broadcast on Facebook or Twitter and ask us questions using the hashtag AskNASA. Or you can leave a comment or a question in that comment box below wherever you're watching. You see the box? Good job. Today we'll be talking about fires. Did you know that at any given time there are multiple fires burning across the globe? Well, during today's show, we'll discuss the real science of fire. We'll look at how NASA monitors and tracks fires, how NASA's data is used in prediction, response, and recovery, and we'll even have the opportunity to speak to a NASA astronaut about how studying fire in space could actually help us here on Earth. Sounds super interesting, right? Well, let's begin. Our first stop will be to one of our NASA labs where we recently visited to learn about the real science of fire. Josh, take it away.
Thanks, Leslie. Today, I'm going to talk to you guys about fire. The fire triangle requires heat, oxygen, and fuel to produce a flame. In the case of this candle, I added heat to a fuel, which was the candle wax, and oxygen from the air combines with that fuel to produce this flame. And this flame, not being an element, is simply those combustion byproducts or gases that are so hot that they're glowing visible to your eyes. Paraffin wax is burning and producing a blue color. And if you look at the base of that flame, you can see there's just a little bit of blue right at the bottom. As that flame progresses upward, it picks up small particles that are being emitted by the candle wick, as well as combustion byproducts of the chemical reaction. And the hotter they get, the color will change. Above that, the flame seems to disappear. The particles are no longer emitting light that is visible to our eyes. But just because it's not visible to our eyes doesn't mean that it's not still hot. To demonstrate the fact that this flame is still there, even though you can no longer see it, I'm going to take this piece of paper and I'll hold it above the candle. And paper likes to burn at about 450 degrees Fahrenheit. Because the paper is not touching the flame, the visible part of the flame, but it's burning now, you can see that the flame is actually still quite hot at this point. Smoke, by the way, looks like a gas, but smoke is not a gas. Smoke is tiny little particles of soot and char that are being emitted into the air as that candle wick cools, and they're so small that they float up into the air. Everyone's familiar with campfires, and you understand that when you try to light a wet piece of wood, it's very difficult to get the campfire going. And there's a reason for this. A lot of the heat is absorbed by the water rather than by the wood, which would elevate the temperature of the wood to its ignition temperature and then begin burning. And I can demonstrate this here by taking this piece of paper and providing a heat source. You'll notice that I readily reach the 450 degree temperature that is required for this ignition to happen, and the paper burns readily. Not a surprise. I'll take a very similar piece of paper, dip it in water. Notice now that most of this energy is being absorbed by the water and not by the paper. So the temperature of the paper is still relatively cool. Understanding these fundamentals help wildfire experts to detect the threat of fire danger. If it's been wet, rainy, or humid, it may help to decrease the chances that the forest could burn. Conversely, if it's been dry and especially windy, fire danger will be high. Understanding these fundamentals of fire science helps fire experts to fight wildfire. Back to you, Leslie.
Wow, that was a fascinating demonstration, Josh. Thank you. Now, here to help us take that science and actually apply it to a better understand what it's like when that really happens in various locations on Earth are Doug Morton and Amber Soja. Hi, and welcome to the NASA Science Live area. So I want to jump right in and glean from your experience and your expertise. We have some questions that we want to ask, and hopefully you'll be able to clear some dark spaces and some cloudy spaces for us. So here we are. We just learned about the science of fire, Amber. How do we actually apply the science of fire to what happens here on Earth?
So NASA not only investigates the stars, but we also focus on our home planet, Earth. And fire science is one of those key subject areas. We could probably break down what we provide in terms of satellite data information, in terms of pre-fire, active fire, post-fire, and also feedbacks between fire and our Earth system. And one example of those is how black carbon could land on snow and ice, forcing it to melt more quickly.
Wow, that's really impressive. So, did you know, Doug, that, most people think of NASA as just a space agency. However, NASA's Earth science is just as important as our space science. How can NASA's unique perspective and research inform the general public about fires?
So Leslie, we have more than 20 instruments on orbit right now, including the International Space Station, and each one of them take measurements that can help us better understand how fires are burning, changing the vegetation around us, the atmosphere above us, and our planet as a whole. And so, as a scientist here at NASA, one of my jobs is to take those different parts of the puzzle and put them together, being able to look carefully at areas that are burning today, where the smoke will go tomorrow, and understand how the smoke that might last in the atmosphere for weeks or even decades can change our planet.
Wow, that's awesome. And so, well, it looks like we have sparked some interest from our viewers. Let's take some questions from #AskNASA. Question 1 that I have is Jesse from Twitter says, how big are the fires we can see from space?
That's a contentious question. Some people will say 1 meter by 1 meter. We can see smokestacks, so that's a hot spot in space. Other people, Louis Giglio, will define it as an envelope of possibilities, depending on how hot, how wide a fire is, and if we're overhead. So that's a difficult question. We can see very small fires, like I said, a smokestack or small agricultural fires. And in a wildland fire, we see a whole line of burning as the fires move across the landscape.
Wow, okay. So Natalie from Facebook says, what can we see when flying in planes?
So NASA has a lot of activity right now. This has been a really busy summer with the OSIRIS-REx campaign taking off and chasing smoke plumes, and an upcoming campaign called CampX that will be flying in Southeast Asia to understand how the smoke that gets released by fires actually can change the tropical monsoon. So from NASA's vantage point, chasing those smoke plumes, we can take measurements that will help us better understand how the smoke that leaves the fire changes as it blows downwind, potentially impacting people with air quality concerns that live thousands of miles from the fires.
Wow, really nice. Okay, so we're going to go back to our experts. NASA research has been in the field tracking smoke from fires here recently. Can you describe exactly what they see from the air and on the ground?
Yes, we can. There are a couple ongoing campaigns right now above that's looking at the Arctic Boreal. And also we have campaigns, OSIRIS-REx and CampX, that are continually ongoing. OSIRIS-REx is a very exciting campaign where we're looking at multiple ecosystems and we're flying our planes through the smoke, our DC-8. And that's quite exciting. You can't see anything when you're in a smoke plume, but we have instruments and inlets on the side of the plane that take in the chemical composition of the smoke and look at it as it evolves over time. And that can impact air quality, not only close to a fire, but downwind of the fire.
Right.
Amber, how many scientists are working together on a big plane like a DC-8 or working on the plane and on the ground at the same time to study fires?
Oh, on the plane is probably about 28. On the ground, maybe another 80 providing support, depending on what the campaign is and what you're looking at. So that is during OSIRIS-REx. People cycle in and out. and it's very dynamic and exciting.
Wow, it sounds like it. So Doug, this June was the hottest June on record, with data showing that July was statistically tied for the warmest month on record. What impact has that had on this year's fire season?
So Leslie, we're living in a warmer and a drier world. And with climate change, we're going to continue to see conditions that make fires more likely. So we've heard from Josh about the fire triangle, and as climate conditions make vegetation and other fuels that are on the ground today more flammable, it's likely we'll see more fires, and the fires that do start will be more extreme. So they might burn faster, they might have a more lasting impact on ecosystems, and they'll definitely be harder to suppress. So as the climate's been warming, we're seriously interested in tracking how fires and fire behavior has been changing.
Absolutely, not surprising. So let's take a couple of questions back from our hashtag #AskNASA. So question says, what's more difficult, predicting where the fires themselves will go or where the smoke will go?
I think we do a pretty good job of both of those. You would need a smaller scale to predict where a fire would go. And we have new instruments such as VIIRS that can look at fire detections with MODIS over time at night. So we can better place resources. Smoke, chemical transport models are doing a very good job of tracking smoke. That doesn't mean we know everything, and we can certainly be better and have higher resolution information because it is important. Where smoke is injected determines how fast it will be transported in time.
Absolutely.
And we are having a hard time getting the injection height correct. That's one area we need to work on.
Okay.
So Leslie, one of the interesting things is that we have scientists that are funded through NASA and here at the Goddard Space Flight Center who are studying all parts of that problem.
Right.
So we can take information that comes from satellites about where the fires are burning, and we can work with our colleagues who've made really detailed models of the Earth as a system, the same kinds of models we're using to predict weather. The combination of those science experts is really what allows us to start to track and predict, even try to forecast where the smoke could be days or weeks from now.
Absolutely. Okay. So we've been talking about the science of fire and the data NASA collects from the air and on the ground. But let's take a look at how the data and information are actually used. In this next video, you'll see how first responders rely on NASA satellite data to see through the smoke and fire, which allows them to track and blaze in near real time.
Our intelligence for the Tubbs fire was all based on the 911 reports we were receiving and the radio reports that we were getting from our fire resources and our law enforcement officers out in the field. And if we had had a bird's eye view, some kind of imagery so that we could get a picture of exactly what we had, that would have been a game changer. We're actually using some of the National Guard's manned and unmanned aerial assets so that we can practice the surveillance of our fires.
That's that aircraft and gimbal line of sight.
One of the major things that we have them help us with is some of the perimeter mapping and determining the exact location of our fires.
A system we heavily rely on is the MODIS satellite system that is provided by NASA, and we use that to see in near real time where those hot spots are of that fire that we're fighting.
102. Okay, we got it.
First responders, they want to know which houses have been damaged as quickly as possible, and the smoke may or may not have been cleared. But using radar, we can see where those houses are and where we maybe need to focus our efforts based on how a wavelength might bounce off of the surface. We can actually see through smoke and clouds. We can see things like vegetation structure or building structures.
So we've got a fire out of our right wing towards the north.
Fire, go ahead and report it.
Prior to having the capability, we would draw by hand basically where the fire perimeter approximately was. Now, with the MODIS data being pulled in, we're able to see irrefutably where that fire was last known to be.
So look, here's what it looks like.
Remote sensing application has been a game changer.
Just as we could see from that example with the CAL FIRE team that depends heavily on getting information from NASA satellites to know where the fires have started and where they'll spread next, NASA satellite data are coming really from the satellite to the smartphone all over the world as that information gets shared. And the MODIS data stream that we just heard about is one of the most powerful and long-term records we have of how fires have changed across our entire planet. This is an example of a MODIS image for the Walker Fire, which is currently the biggest fire burning in the lower 48, about 50,000 acres, and it broke out just in the last couple of days. And so the MODIS imagery we have will tell us where the location of the actively burning fire is. It'll also help us better understand the way in which the smoke that gets transported from that fire can change air quality, making it difficult or even dangerous for people living not just close to the fire, but also who live thousands of miles away. NASA satellites have a view of the Earth every day and every night, and that allows us to not just focus on places like California, but you might also have heard that there have been fires across parts of the Amazon region. And this is, again, where NASA satellite data provide a really critical window into fires that are burning in really remote locations. What we see when we look at the MODIS imagery from earlier part of August, we see the fires coming from areas of active deforestation. These are areas where people have cleared additional rainforest to make room for cattle pastures and for croplands, and they're using fire as a way to clear those areas. We know that they're burning wood in those locations because we can see that the fires are so intense that they put the smoke from those fires high up in the atmosphere, where it spreads downwind and can end up creating air quality conditions in the regions of Brazil, Peru, and Bolivia, far downwind from the active deforestation frontier, that are among the most unhealthy air quality conditions we've seen anywhere in the world in the last month. NASA satellites can also see things that our eyes can't see. So as we're tracking fires in the Amazon, we're also using information like the data I'm showing here from the AIRS instrument, which has collected information about how carbon monoxide, one of the gases that gets released when fires are burning, we can see how the carbon monoxide that's released from these fires pools up over the Amazon region and ultimately flows south, showing us how smoke that began in the Amazon ultimately changed air quality over the cities of São Paulo and southern Brazil, affecting millions of people. So really what starts in the Amazon doesn't always stay in the Amazon, and using NASA satellite data allows us to track that more carefully, looking at conditions that are important in terms of understanding ecosystems and air quality, as well as the rest of our Earth system. So if we go back and look now at the MODIS data that were collected over just the last several days, we can continue to see the way that fires are burning across these landscapes. Those fire detections will help us better understand how fires are changing ecosystems, how fires are changing the greenhouse gases that get released from fires into the atmosphere, and ultimately how that mixes with the atmosphere and changes the atmospheric composition. It's not just places like the Amazon that dry out every year, sending smoke down to places where people live. Our scientists have also been out in Canada and Alaska as a part of the Above program. So let's go join Lauren Ward, where she learns a little bit more about how fuels in the boreal forest are also lighting fires.
Mike, thank you so much for joining us on this bug-filled expedition into the forest here. So can you tell us what you actually did in the field today?
Yeah, so today we were out in an area that had burned in 2015, and we're measuring soil moisture in that plot in the burned area, and we're also measuring what's regrowing in that area. So we have soil moisture probes that we use to measure the moisture content of the soils, and then we have little plots that we set up 1 meter by 1 meter squares where we will measure what's regrowing, trying to understand how the forest is changing.
Yeah, thank you so much for giving us an idea of what's happening around here, and we really appreciate it. Thanks a lot.
Very welcome. Thanks a lot.
Cool.
Thanks, Lauren. Beautiful country, but lots of bugs. We'll stay here in the studio. So thank you, Doug, for joining Amber and I back on the sofa. So I want to ask a couple of more questions of you. So let's talk a little bit more about the Above mission and the field campaigns. Why do scientists actually go in the field, and how often do they actually go, out to do the research hands-on?
I think we can both answer that question. We're always in the field, and we're in the field in different places. We are in the field in the tropics, and the forest steppe, and deserts, and the temperate environments where most of us live, and also in the boreal environments, which includes Canada and Alaska and Russia. We also study the Arctic. So in all these systems, we go on field campaigns. Above is one of the field campaigns that studies the Arctic and boreal. Also ongoing right now is OSIRIS-REx, which is a NASA NOAA campaign. And the objective is to investigate smoke and fire in a variety of ecosystems and hook it to the actual ecosystems. This is completely new science. We've never done anything quite this extensive before. And we're not only focusing on the western fires from Boise, but also from Salina, Kansas. We're focused on agricultural and croplands and small fires and prescription burns. So it's a very exciting science.
Doug, would you like to add to that
Sure.
just a little?
I think it's interesting to think about how NASA scientists who are really focused on making measurements at all different scales, we're making a good pitch, I think, with that video of Lauren and the bugs for doing airplane-based research, because we're high above the bugs when we're taking the chance to use new NASA technology to make maps of really detailed maps and high-resolution images, or using lasers to map ecosystems in 3 dimensions. And each of those parts of our science helps link together a better understanding of how those ecosystems are changing in response to fire as well as in response to warming climate.
Right, great. So let's take a couple of more questions from hashtag #AskNASA. Jennifer Ingram from Facebook asks, what sort of education does one need to work in NASA's jobs that involve fire science?
Wow. We can come from all different directions. My background is in environmental sciences, so it's in pulling together different systems and modeling in ecosystems. And then fire is a way that carbon is cycled, so I became interested in what was happening on the ground. What was this about climate change? Was it real? Wasn't it real? And so fire was a way that I could look at the way carbon was cycled in ecosystems, and that led me to my focus in Siberia. And that's where most of the carbon is stored. Most of the terrestrial carbon is in the boreal environment, and 2/3 of that is in Russia.
Wow, okay. And so, Amber, let me, ask you a question. How exciting was it to be actually out in the field? That's actually one of the questions that's here on hashtag.
Oh my goodness!
So yeah, how exciting was it?
Incredibly exciting, both in Siberia and also in the DC-8. We just talked about bugs, but there was one fly in the DC-8, and even though it was one fly, it did wreak havoc. In Siberia, the bugs were so bad that we covered ourselves with masks, but every bit of it was incredibly exciting. The camping outside, the being helicoptered in, studying the amount of fuels and how they could change depending on the fire and weather and what is released and how it differs. It just was all incredibly exciting.
Right. Okay, so, Amber, you've talked to us about being in Siberia, but we understand that you were recently in Kansas and in Idaho on the FireX AQ. Tell us a little bit about what you do. What's your actual job when you are out in the field and what you do when you're on travel?
Well, I was able to go on the DC-8 a couple of times, one a prescribed fire, and also both in Salina and out of Boise, so looking at both types of fires. Also, my primary job was as a forecaster. And so that was forecasting during the day where I thought the best fires were to fly. We had a whole team of forecasters. I was certainly not alone. We had meteorologists and people looking for larger smoke. And we also forecasted in the east. It was quite different because then we were using small hotspots and GOES detections in order to determine what fires were most active, and we had to catch them quickly because they only burned for 15 minutes. So the plane was hopping from place to place, sniffing a lot of fires in the east, and in the west, we took our time flying back and forth.
Wow, sounds like you really enjoy your work, Amber.
I do.
Okay, so you guys are really asking some really great questions. Please continue sending them by using the hashtag AskNASA about leaving those comments in the comment stream down below in that box. We'll try to come back to some questions a little later in the show. So we have heard from NASA studies, about the fires in the satellites, aircrafts, and even going into locations on Earth. But there are some other places where we're working to better understand those blazes, and that is the International Space Station. You weren't expecting that, were you? Astronauts on the orbiting laboratory not only have a bird's eye view of fires on Earth, but also they are conducting experiments in microgravity to better understand the physics of flames. We can learn a little more about that from astronaut Randy Bresnik, who's with Dan at Johnson Space Center.
Thanks, Leslie. Hi, everybody. I'm Dan Hewitt, and I am fortunate to be joined by an astronaut. You can tell by the blue suit. This is Randy Bresnik. Randy, thanks for being here. I really appreciate it. Randy spent time on the International Space Station. Give us 30 seconds. What is the International Space Station?
The most amazing technological achievement humans have ever built. It's 250 miles up, going around the Earth at 17,500 miles an hour. We've had humans up there for the last 19 years continuously. Hundreds and hundreds of experiments going on all the time.
And so today we're talking about fires. Being up there, you're about 250 miles over the Earth. You get a pretty unique vantage point, don't you? And you guys can actually see fires down here on Earth while you're up there.
Absolutely. I was happened to be on the phone. They said, hey, have you seen the fires in California? What fires? As we come over the horizon, before I could even see the coastline of California, you could see the smoke. And as we get closer, all of a sudden the smoke is engulfing the whole northern part of the LA basin. And having grown up in Santa Monica, it was just amazing to see the scope of the fires that were going on at that time.
And so that's something, you had seen growing up down on the ground. What was it like to really kind of get the full scope, the magnitude of it from space?
It's surreal because everything on the ground is so small normally. Yeah. And to see something this big, it was astounding. So we're able to give real-time data to folks on the ground, whether it's emergency management or scientists, about here's the scope of it, here's how it's changing. 90 minutes later, we come back over it again.
Yeah. And so you're not just looking at fires down on the ground, though. You guys are actually starting some fires in a very controlled environment on board the space station. What kind of research are we doing, actually inside these special modules?
So, typically in aviation we say the only thing worse than a fire on the ground is a fire in the air.
Yeah.
Well, fire in space is even worse than that. One that we had on the Cygnus that comes up and brings cargo up, and then when we're done we fill it with trash and it burns up in the atmosphere. Well, there's an experiment called Sapphire on that. We lit a fire on purpose because we were going to burn up in the atmosphere later, so it didn't
and this
really
is
matter.
after it had left.
Yeah, it's after it left space station. And look at how fire burns on fabrics and other materials, and find out that, hey, if we lower the pressure, the flame doesn't spread as fast. So does that give us, inputs between the ability to figure out, hey, if we build our spacecraft and operate them with slightly lower pressure, then are we making them less fire, or more fire safe and less chance of the fire propagating?
And I mean, learning how to fight fires in space, that's something that fighting a fire in space almost definitely has to be different from just grabbing a fire extinguisher down here on the ground and just kind of zapping it.
Absolutely. You are the fire.
You're on it right now.
And so we have to get on it right away. But think about it, for everybody who's ever seen that movie WALL-E, where he's flying around with a fire extinguisher, guess what? The fire extinguisher is that propulsive. And so that's something that we have to take in consideration when you're fighting a fire. We have to locate the fire, get the right equipment, have our breathing apparatus, and then be in a position to hold ourselves or have our crewmate hold us so when we push the fire extinguisher release, that doesn't propel us out away from the fire.
Did you ever get a chance to test that when you were up there?
Fortunately, we did not. I'm good with the fact that we had no fires.
You don't have to check them every once in a while, make sure they don't need a recharge, maybe?
No, we check the gauges.
Jump around a little bit?
Yeah.
Okay.
Yeah, fire extinguisher races someday, but not on the space station.
Not on space station. All right. Well, Randy, thanks so much for giving us that quick overview. It's amazing stuff. Leslie, we're going to send it back to you. Talk more about fire.
Thanks, Dan, and thanks, astronaut Randy. Oh, wow. Where did all the time go? It looks like we're moments away from being completely out of time. But before we go, I really want to thank you all for joining us today to discuss NASA's role in studying fires across the globe. And a special thanks to our studio guests, Amber and Doug, for being with us today. Thank you so much. Before we go, I want to share an exciting trailer that we have for our third season of NASA Explorers video series, which is all about fires. And again, thanks so much for watching, and until next time, remember to keep looking far and beyond the stars, for there's a lot more yet to be discovered. Thanks, and bye-bye.
I feel like the work that I do, the knowledge that I'm trying to pull together, is important for the human race, for our country.
When the opportunity came along to do this type of work, I really resonated with it.
With better science, you have better information. And with better information, we can all make better decisions.